Hello and welcome to my Pre-Algebra review series. This video covers Chapter 9, Section 2 of your Big Ideas textbook, titled Lines of Fit. By the end of this video, you will have reviewed recent lessons regarding lines of fit and how you can use data to better predict an event. You will review methods for finding lines of fit, and you will find a line of best fit using technology. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and it certainly will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's do some math. So a key idea, line of fit. A line of fit is a line drawn on a scatter plot close to most of the data points. It can be used to estimate the data on a graph. So I guess what that's saying is there's a bunch of points on a graph, and they're all spotted kind of near a line, some type of a line you could draw through the points, and all the points will have a relative closeness to that line. We just looked at that in a previous slide, so I know you're familiar with it. Graphing calculators use a method called linear regression to find a precise line of fit, and that line is the best line of fit, the line of best fit. This line best models a set of data. A calculator often gives a value R called the correlation coefficient. It's the value R. You're going to see that in the future here, and they call it the correlation coefficient. This value tells whether or not the correlation is positive or negative and how closely the equation models the data. This linear regression equation. Values of R range from -1 to 1. When R is close to 1 or -1 or -1, we'll say -1, there is a strong correlation. Okay, that means that the data, you have a line on your graph and the dots are really close to that line. That means that those dots follow the X value very closely. So whatever X is, you can pretty much predict what Y is going to be because it fits very close. And it could be a negative or a positive. So the closer it is to 1, it's a positive. X goes up, Y increases. If it's close to -1, as X goes up, Y decreases. It's that negative. We've seen those also recently. There is a strong correlation between the variables if you're close to 1 or -1. As R gets closer to 0, the correlation between them weakens or becomes weaker. Okay? So if it was down like 0.2 or 0.15 or 0.4, that means that the data kind of correlates, but not real close. It's scattered around the line. You can imagine that the data is following the line, but maybe sometimes you won't. So there's a strong correlation or no correlation. If it's 0, there's no correlation. That says that data is like it's just a scatter plot that doesn't correlate to anything. It doesn't matter what you put a value in for X, you cannot determine what Y is going to be. Okay, in example 1, it says finding a line of fit. They've given us the data. You see the table. It's a depth of a river. It says the river depth is the title of the table. So the depth of the river in feet on the y-axis and months on the x-axis. And those months we're going to hear what those months are about. So it says the table at the right shows the depth of a river X months after a monsoon season ends. So monsoons come, you get this heavy rain, and the rivers get higher and higher and higher, and eventually the rain stops. Well, what they're telling us here is that this monsoon stopped, and we have a set of data. How deep was the river when the monsoon stopped? And they're saying here, you're going to see that 0 month is the end of the monsoon. When the chart says 0, that means that's when the monsoon ended. So let's see what it says. The table at the right shows the depth of the river X months after a monsoon season ends. A, make a scatter plot of the data and draw a line of fit. Well, the plot is here. That you see the data points here. They randomly, every month, you see they went down the line here, and every month they took a reading of how deep the river was. So 1 month after it looks like about near 19 feet. 2 months later, it was somewhere near about 15 feet. So you see it's kind of moving down as the months go on. At the very end, it looks like at about 10 months, where it says X right here, the X scale, but 8, 9, 10, it looks like the line's crossing there at about 10. So that would kind of imply that at the end of 10 months, the monsoon is back to exactly probably where it started before the monsoon. I mean, I don't know, I'm making that up, but that's kind of what the chart's telling us. Okay, so make a scatter plot to show the data and draw a line of fit. Write the equation of the line of fit. And so in order to write the equation, we need to know what is a line of fit and how do you write the equation. So we're going to talk about slope, right here, slope. Okay, and slope is defined as the rise or fall, the rise in your y-axis divided by the run in your x-axis. And the run always goes from left to right. X always goes up, but the y can go up and down. You know, you could be losing in 2 months. You could be losing something as opposed to gaining it. Okay, so that's how you do. And in this case, what is the slope of this river? The data chart for this river. Well, easily we can see, since the line crosses the y-axis at x 20, here's x is 0 and y is 20 right up here. So we know that that's a point. We can count on that point. And it also looks, it says, and that's at y, the y-intercept of 20. So that's this is where the line crosses the y-axis. We call it the y-intercept. And we know that -2 is the slope. And how do we know that? Because if you start over here at 0 and you're at 20 and you go 10 plus 10 in the x direction and you've gone down 20 to 0, you got negative, right? So that means you're going negative. You're not going positive, you're going negative. So it's negative. And what is it, 10 or 20 divided by 10, which is 2, -2. Okay? Minus 20 divided by 10, -2. And here that is right here, -2. That's how they came up with that one. There's other ways of coming up with it, but that's how this particular points were chosen. So C, interpret the slope of the y-intercept of the line of fit. The slope is -2 and the y-intercept is 20. Therefore, the depth of 20 feet at the end of the monsoon season, and it decreases 2 feet per month. So in 10 months, it's decreased 20 feet. Every month, it decreases 2. Okay. Predict the depth in 9 months. So we're going to write the equation using the derived equation. And that derived equation is called the slope-intercept form of the line. And I know you've studied this already, the slope-intercept form of a line. And I can tell you that you've seen it. It's y equals mx plus b, where m is the slope and b is the y-intercept. And I know you know this. So here we have y is mx plus b right there. Well, m is the slope, and here's the slope, -2. X is the value of the x value on the x line. They said after 9 months. They want to know at 9 months right here. After 9 months, I drew the dot there, but we're going to find out in the equation that that's where that is. In 9 months, and we started at y equal to 20. The y-intercept way up here. So if you run the equation, -2 times 9 is -18. Plus 20 is what you started at, plus 20. That gives you 2 feet. The river will be 2 feet deep at the end of 9 months. And if you look here, guess what? We go along the line here, and guess where is it? Right here. It's at 2 feet. It came up at 9. It happened to be that way, but I mean, it could have been off a little bit, but this one happens to fit pretty darn good. So there you have it. In 9 months, the river will be about 2 feet deep. And in some of these countries, when there's monsoon seasons, the river only exists when the monsoon comes. After it dries up, it goes to 0 feet. It's just a dry desert bed. And they're waiting for the next monsoon to come to fill that river up again. Okay? Good. Exercise 1. On your own, you're going to try this and just see how it turns out. So it says the table at the right shows the number of people who have attended a festival over an 8-year period. Each year, they're telling you how many people attended the festival. Make a scatter plot of the data and draw a line of fit. So you're going to spend time, you're going to take and try to fill out the chart or something similar. You'll have a chart at home. Make it up, 1 through 10 and, 1 through whatever. This says 2,400, so if I go up by hundreds, that's what this chart here, it goes up by hundreds, or it goes up by 200s, actually. But you can figure out some approximation of a chart. It says, after you've done that and drawn the line, then you're going to try to write an equation of the line of fit. Can you define that? It's going to be a linear equation, y equals mx plus b. You get into the slope and the y-intercept. And then interpret the slope and the y-intercept of the line of fit. What is it telling us? That's what they're asking. And then predict, using your equation, how many people should attend in 10 years. And realize that we're all going to get different answers on this. So they're going to be close enough. You need some type of a calculator to give you exact numbers. We're just going to be drawing rough lines and trying to eyeball it. So go ahead. When you get done, come on back and we'll try it out. Okay, now I'll assume that you're back. I've got some dots on the plot here, and we know what's being asked of us. So I've plotted this out. And when it says make a scatter plot, we've done that. It says draw a line of fit. Well, I'm not able to draw a very good line, but I'm going to assume that the line is going to come along down in here along my points, right? This kind of a straight line right in here, right? Kind of like that. And it's going to go up there somehow like that. It's not a very straight line, but you get the picture. And then from there, we're going to try to figure out a slope of some type. So if I say that in here that the slope around here that was a dot, and that was on year 7, we had, let's say 1750. So I'll write 1750 over here. 1750 at year 7, right here. And then we have one down here. Let's say it's 500-ish. 500 at 2. 500 at 2. So that means we've got 1750 minus 500 is 1250. And we're dividing 1250 by 7 minus 2 is 5. 1250 divided by 5. Hold on 1 second here. We'll get out the calculator. And 1 second. Oh. Okay, it comes out to 250. Now that I look at it, of course, it should have been easy to figure that out. So there we have it. So it looks like the slope is rising, it's positive, and it's going up at the rate of about 250 attendees per year. Okay, so if we do that, we can write an equation now. I think we can write an equation. It's just write the line of the equation here. So far we know that y is equal to mx, and m is now 250, and it's positive. X is the year, right? And it's got to be a plus b. And we want to know what is the y-intercept. Well, the y-intercept is going to be if x is 0, what is y? If x is 0, then we're going to look back here and we're going to say, well, it looks like it comes down in here at about, I don't know, 170 maybe, somewhere down in there. It's hard to say. So we're going to say plus 170. So given those numbers now, we can go back and run the equation. It says, so interpret the slope. So the slope says that every year, the attendance is going up by about 250 people. And that when we started off, we had 170 people attending. Is kind of what our line of fit tells us. And then it says interpret the slope. I just did that. Predict the number of people who will attend the year in year 10. So in order to do that, all I'm going to do here is I'm going to write y is equal to 250 times 10 plus 170. So that's going to come out to y will be the attendance for year 10 is going to be 250 times 10 is going to be 2,500 plus 170 is 2,670. That's what the interpretation that would be. And hopefully your numbers are somewhere close to that. Okay? Good deal. Thanks. Okay, so now for example 2, finding the best line of fit. So now what we're doing is we're taking this table of data, and the table is given to us right here. I'm going to change pen colors. So the table is given to us right here. Best line of fit is what we're looking for. So the table shows a worldwide movie ticket sales Y in billions of dollars from the year 2000 to 2011. Find X, where X represents the year 2000. Use the graphing calculator to find the equation of the line of best fit and identify and interpret the correlation coefficient. Well, this I'm not going to be able to teach you how to use that calculator. I'm sure you all know how to do it. But in essence, you take your X values, which are right here, X values, and your Y values, and you enter them into the calculator. So if this were my calculator over here, on this side, my calculator, in column X, so there's columns that you put under stat, right? And you fill in your data on your L1, L2, L3, L4. This is like L0 and L1 or L1 and L2. You're going to fill in your first row of values, which is 0 to 11. And then you're going to fill in your next row, which is your L2 row. It's Y1 here, 16, 17, 20. These are all your values. And then you're going to run it and calculate it. And you're going to get the slope. You're going to get a picture of the line. If you graph it, you're going to get the y-intercept. You're going to get the R coefficient. You're going to get everything you want from your calculator. And that calculator will give you a line of best fit. And in this case of this data, with the calculator I used, I put in the data values that are right here on the chart, ending at 33 right here. My 33 is right here for year 11. We see that the y-intercept, according to this calculator, B, right here, B is around 16.29, 16, almost 1700, but 16,300, 16.3, okay? Somewhere in that, closely in that neighborhood. So what 16 is kind of close, and the slope is 1.5. So this is going up at an angle of over 1, up 1.5. Over 1, up 1.5. That's what it means, 1.5. Okay? So that's what's going on here. The equation is y is equal to 1.5x plus 16. And like I said, my slope value is 1.5. And 16.3 is my y-intercept. And my R value, that says that we have a very tight correlation. You see the dots fall along that line. Pretty good, all except for like this one outlier right here. We have one outlier right there. Except for that, R says it's 0.9818. That's very close to 1. And since it is a positive number, you know that the slope is going up. Okay? So that's kind of important. So we now know all that information. Okay, it has a tight correlation. Okay, now on your own, you can do the same thing. We have data here. We have the plot, okay, of that data. It says using a graphing calculator to find the equation of the line that best fit for the data in example 1, identify and interpret the correlation coefficient. I'm just going to ask you to do it. I'm not going to hide the numbers or wait. We'll just go ahead and wait for you to do it. Type in your numbers, because you can't duplicate my chart that easily, or you have to type it in your calculator to duplicate my chart. But after you type those numbers in, here they are with 0, 1, 2, 3 to 8, and 20, 19, 15, 13, 11, 10, 8, 7, 5. As you get those all plotted in on your calculator, and you tell it to run the equation, you're going to come up with numbers that should look very similar to this. Using the y is equal to mx plus b. That's what this equation is. It's linear regression. Okay? We see that the r value is negative 0.988. Well, that's a very tight correlation. And guess what? Look how tight those. Even this one, it's a little bit of an outlier. He's not as much of an outlier as that other one was. But look at how close that correlation is there, and he's telling you. And he's saying it's negative, so that means that the slope is going down. We know that. Okay? And if I look at the slope m right here, the slope m, it says negative 1.8, I think 88333. 1.88. That's the slope. Over 1, down 1.88. Over 1, down 1.88. Negative. And the y-intercept is, according to this, about 19 and a half. And if you look back here, you see that the line, this line right here, the line crosses right there at about 19 and a half. That final dot there is a little high, but that's the y-intercept of our equation. I hope when you did this with yours, run it. You see these numbers. Run it on your equation. Hopefully you'll get these exact results. You type it in column 1, your L1, your L2, tell it to calculate and graph, and you should really get the same numbers. Like I said, I can't do your calculators. I don't have the capability to do that. But you should all know how to use the stat function and edit and pick your linear regression equation and edit. And if not, you need to ask your teacher to go over that with you again in class, after class or whatever, but you need to be familiar with this. Okay? Good.